Okay, we are going to skip section 3.2. 3.2 is building quadratic functions out of quadratic data. So we'll do section 3.3 here. 3.3 is called quadratic functions and their properties. A quadratic function is a function of the form f of x equals ax squared plus bx plus c equals 0, and a is not 0. A, b, and c can be any real numbers. A cannot be 0. Essentially, we're going to be graphing parabolas in this section. That's what a quadratic is. Two methods for graphing a parabola. Method 1, we're going to follow a list of steps. Step 1 is to check if the parabola opens up. A is positive if it opens up, or A is negative if it opens down. A can't be 0, remember. Find the vertex. V equals the point negative b over 2a and the f of negative b over 2a. This is the highest or the lowest point on the graph. Okay. Then problem 3, find the axis of symmetry by letting x equals negative b over 2a. That's always going to be the x-intercept value, you'll see. Step 4, find all the intercepts, and then step 5, plot more points if necessary and sketch the graph. In the first example, suppose that f of x is equal to x squared plus 2x minus 3. Okay, so step 1 is to identify A. A is 1, which is greater than 0, so the parabola opens up. And step 2, we're going to calculate V, negative b over 2a. Negative 2 divided by 2 times 1 is negative 1. F of negative 1. F of negative 1, 1 minus 2 minus 3 gives me negative 4. Negative 1, negative 4 is on the graph. Okay. Step 3 is the axis of symmetry. The axis of symmetry is always the x value on the vertex. So x is equal to negative 1. And use a dotted line to graph an axis of symmetry. And basically all we're saying there is that you could rotate the parabola about that vertical line. In other words, that's going to be a line of symmetry. Okay, step 4 is the x and y intercepts. The x-intercepts, I let y be 0, and I solve for x. Y and f of x mean the same thing. X plus 3 times x minus 1 equals 0, so x equals negative 3 and x equals 1. Okay, and f of 0 is negative 3. So 0 and negative 3 is on the graph. 1, 0, and negative 3, 0. Okay. Step 5 is to graph the parabola. I've got these 3 intercepts on the graph. I also know this point, the vertex. And so using those points, I can draw on the parabola, draw it in as best you can, and that would be the answer to the first problem there. Next is f of x equals negative 3x squared plus 6x plus 1. A is negative 3, and that indicates that the parabola opens down, since that's a negative. V equals negative 6 divided by 2a is negative 6. Negative 6 over negative 6 is 1, f of 1. Negative 3 plus 6 is 3, plus 1 is 4. 1, 4 is on the graph. X equals 1. Okay, so I can spin the graph about the vertical line, and x equals 1 is the x of symmetry. The x-intercepts, negative 3x squared plus 6x plus 1 equals 0, means that x is equal to opposite of b, negative 6, plus or minus the square root of b squared, negative 6 squared is 36, minus 4 times a is negative 3, times c is 1, over 2a, 2 times negative 3 is negative 6. 36 plus 48, plus 12 is 48. And root 48 breaks down nicely as 4 root 3. Okay. But I don't think that much matters, though, since I would go to the calculator and type it in the numbers there. So negative 6 plus the square root of 48 over negative 6 is negative 0.15. Negative 6 minus the square root of 48 over negative 6 is 2.15. And those are approximate numbers there, so be sure that you get the approximation sign. The y-intercepts, let x be 0 and solve for y. Well, when x is 0, we get f of 0 is 1, and so 0, 1 is on the graph. Okay, there's 0, 1, there's negative 0.150, and there's 2.150. And here's 1, 4. Okay, I've got the axis of symmetry drawn, and I got a parabola that opens down. Okay. Next is f of x equals 3x squared minus 3x plus 2. A is 3, and that's a positive number, so the parabola opens up. The vertex, negative b over 2a, 3 divided by 6 is 1/2. F of 1/2 is 5/4, so 1/2, 5/4 is on the graph. X is 1/2, I've already said that. So that's where I've got the axis of symmetry located. The x-intercepts, x is equal to that, negative b, which is 3, plus or minus the square root of b squared, which is 9, minus 4 times a is 3, times c is 2, all over 2a. 2 times 3 is 6. And 4 minus 24 gives me negative 15. So I've got 3 plus or minus the square root of negative 15 all over 6. Since that's the square root of a negative, there's not a real number, so there's no x-intercept. No x-intercept. And that should make sense if I've got a parabola facing up and the vertex is at 1/2, 5/4. There's going to be nowhere where the graph is going to cross the x-axis. So f of 0 is 2. That's the y-intercept. The graph will always have a y-intercept. And I guess this would be a rare time where I'd probably want to graph one more point. So if x is 1, 3 minus 3 is 0, plus 2 is 2. 1, 2 is on the graph. So 0, 2, 1, 2, and 1/2, 5/4 are all on the graph. Another method for graphing a parabola is to use what we know about transformations. As a note, the function must be written in the form f of x equals a times x minus h squared plus k to apply method 2. The vertex is at the point hk. So f of x equals 3x squared plus 12x plus 12. Okay, so if I look at the first two terms, 3 is in common to those two terms. I can factor 3 out. 3 times x squared plus 4x plus 10. Not any different from the original function, but here's where it gets different. I need 1/2. I need half of a, half of b squared. Okay, so 3 times x squared plus 4x plus 4 plus 10 minus 12. Minus 12, where'd that come from? Well, 3 times 4 is 12. I don't have a 12 there. So to make this go to 0, I need a minus 12 in order to make this be 0. Now, the reason for this expression is because the factors are always the same. So I got 3 times x plus 2 squared minus 2. 2 is half of the number in front of x squared. Okay? So half of the number in front of x. Yeah, 3 times x plus 2 squared minus 2. The first graph is always y equal x squared. That's what I'm going to start off with. 0, 0 is on the graph, 1, 1 is on the graph, negative 1, 1 is on the graph, 2, 4 is on the graph, negative 2, 4 is on the graph. Y equal 3x squared is the next graph that I would draw. And that's going to vertically stretch the original graph by a factor of 3. So 0, 0 is on the graph, 1, 3 is on the graph, negative 1, 3 is on the graph, 2, 12 is on the graph, and negative 2, 12 is on the graph. Both those points, 2, 12 and negative 2, 12, are off the scale that I've got. So I'll just stick with these 3 points the rest of the way. Y equals 3 times x plus 2 squared. Means that I'm going to shift to the left 2 units, and with all these points that I've got there. So 0, 0 is going to be at negative 2, 0. 1, 3 is going to be at negative 1, 3. And 1, 3 is going to be at negative 3, 3. Okay? The last graph is my answer. Y equals 3 times x plus 2 squared minus 2. So the minus 2 would indicate a shift downward of 2 units. Negative 2 is on the graph. And by the way, that would be the vertex. Negative 2, negative 2. HK is the vertex. Okay? And so I've got this form that I'm in. X minus negative 2. Well, x is negative 2, and h is negative 2, and k is negative 2. Okay, and so that's good. Negative 1, 1 is on the graph, and negative 3, 1 is on the graph. Okay, when I shift down 2 units. So that was good. Okay, if I graph, let's say one more here. F of x equals negative 2x squared plus 12x minus 17. Then f of negative x is equal to negative 2 times x squared minus 6x minus 17. Okay, nothing's changed there. So now I want to take half of the number in front of x squared. Well, half of negative 6 is negative 3. Negative 3 squared is 9. Okay, so I've got negative 2x squared minus 6x plus 9. Minus 18. Negative 2 times 9 is minus 18. Minus 17 plus 18. So the plus 18 gives me 0. And it's like I've done no harm there, I've added 0. So this expression is the exact same as this expression. Okay? Just like up here, this expression is exactly the same as this expression. Now the reason for doing that is because x squared minus 6x plus 9 factors, and the factors are the same. Negative 2 times x minus 3 times x minus 3 plus 1. Or negative 2 times x minus 3 squared plus 1. if I start with y equal x squared as the first graph, and by the way, you're always going to start with y equal x squared in the first graph using the second method, since you're using transformations on y equal x squared. Then y equal negative 2x squared means that I multiply the y values by negative 2. So 0, 0 is on the graph, 1, negative 2 is on the graph, negative 1, negative 2 is on the graph, negative 2, negative 8 is on the graph, negative 2, negative 8 is on the graph, and 2, negative 8 is on the graph. Okay, 2, 8, and 2, negative 8, and negative 2, negative 8 are off the scale that I've selected. So I'll stick with these 3 points the rest of the way. And by the way, I've got I have a reflection about the x-axis, and also this parabola is opening downward, okay, because of the negative 2. Y equals negative 2 times x minus 3 squared. Well, so I go to the right 3. 3, 0 is on the graph. 4, negative 3 is on the 4, negative 2 is on the graph. 2, negative 2 is on the graph. Okay. And y is equal to negative 2 times x minus 3 squared plus 1 means that I'd shift up 1 unit. 3, 1 would be on the graph. 4, negative 1 would be on the graph. And 2, negative 1 would be on the graph. And we've still got a parabola opening down. And by the way, 3, 1 is the vertex. 3, 1. Okay. The negative 2 has nothing to do with the vertex. Same thing with the 3. That's right there. It has nothing to do with the vertex. Okay. Let's stop right there, and we can finish the rest in the next video.